We're now going to look at some algebraic ways to help us compute inverse functions. So first we're going to review the definition of inverse functions. Then we're going to show the process of finding an inverse function of a given function. That's going to help us find an algebraic way of finding inverse functions. And then we're going to look at how that works on an example. All right, so let's let f be a function. The inverse function of f, and again we call that f inverse, is a function that does two things. It does a couple of things. It cancels out f. It's another way of saying that is it satisfies f of f inverse of x equals x and f inverse of f of x equals x. And all that's saying is that if you do either f inverse first and then f, or f first then f inverse, then you end up exactly where you began. So for instance, if you have f of x equals 4x plus 7, our f, the actions that f do to the inputs is they takes the inputs, multiplies it by 4, and then adds 7. So if you want to cancel that out, you're going to peel that back and do the exact same, or cancel out each action in reverse. So you're going to subtract 7, then you're going to divide by 4. So you're going to start with x minus 7, and then divide it by 4. So that means f inverse of x is equal to x minus 7 divided by 4. Here's another way of looking at that same process. You have f of x and you have x. And remember, the idea is you want to do some actions to 4x plus 7 to get it back to x. And then on the right-hand side, you do those same actions to see what the inverse function does to the input x. So, for instance, when you subtract 7 from both, right? So we subtracted 7 from 4x plus 7 to get to 4x. And then we're going to do that exact same action on x to get x minus 7. Then we're going to divide by 4 to get x on the left-hand side. And on the right-hand side, we get x minus 7 over 4. And if you look at this process in kind of a cockeyed way, it looks a little bit like we're solving an equation for the x on the left side of the table, right? So we have 4x plus 7 on the left-hand side of the table. We have x on the right-hand side of the table. And we're kind of solving for x on the left-hand side. So we end up with x on the left-hand side and x minus 7 over 4 on the right-hand side. So if we want to make this a little bit more like solving an equation, we can actually say, well, I mean, those x's are different, right? So the x in the 4x plus 7 is an input of f, and the x on the right-hand side is an input for f inverse. So we want to give them different names, at least at the beginning. So I'm going to say f of x equals y instead of f of x equals x. So we can keep track of which variable is which. And then we're going to solve for x on the left-hand side. So here's what we have with 4x plus 7. When we're going to subtract 7 from both sides to get 4x equals y minus 7. And then x equals y minus 7 over 4. And as you can see, this completely mirrors the process in that table above. It's just instead of having x on the right-hand side, we had a y instead. And then all we have to do to get f inverse of x is we have to change the y into x. So instead of having y minus 7 over 4, we have x minus 7 over 4. Okay, so let's go ahead and try this on an example that would be very difficult to do in the old-fashioned way. We have f of x equals x over x plus 1. So we're going to set f of x equal to y, and then we're going to solve for x. So f of x is x over x plus 1, so we get x over x plus 1 is equal to y. First thing I want to do is get rid of that darn denominator, so get rid of the fractions. So we can go ahead, in the process of solving x, we're going to go ahead and multiply both sides by x plus 1. So we get x plus 1 times x over x plus 1 equals x plus 1 times y. On the left-hand side, those x plus 1s are going to cancel to give us x. And then we got equals xy plus y. Now, we want to solve for x by itself in terms of y. So even though we've kind of solved for x right now, it has an x on both sides of the equation, so that's not what we're looking for. So what we're going to do to solve for x is get all the x's on one side, because that's what we're solving for. And now we're going to do, well, it's kind of hard to see what we're going to do, except that it's actually going to be the same as we do for solving any equation. What I'm going to do is I have a common factor of x in each of those terms on the left. I'm going to factor out an x from both of those terms. So when I factor out an x from x, I just get 1 left over. When I factor out an x from xy, I just have y left over. So I end up with x times 1 minus y. And now I can solve for x by dividing both sides by 1 minus y to get x equals y over 1 minus y. Now that y over 1 minus y, that's going to be our f inverse of y. We, of course, want f inverse of x. So all we do is wherever we see a y, we turn it into an x. F inverse of x is equal to x over 1 minus x. So try out these techniques on the activities on the PDF file with this video. It's called Advanced Inverse Functions.